Every triangle, no matter how large, how small, or how oddly shaped, hides the same remarkable secret. Somehow, these three angles always add up to exactly 180 degrees. But why? Why should stretching a triangle or moving its corners never change that total? Today, instead of accepting this as a rule, let's discover why it has to be true. Let's begin with a simple experiment. We'll keep changing the triangle. Taller, wider, sharper, flatter. Every time the angles change, and every time their sum stubbornly remains 180 degrees. It's almost as though the triangle is trying to preserve something. But experiments only tell us what happens. They don't tell us why.
Imagine this triangle is made of paper. What if we cut off each of its three corners? Now let's bring those corners together. Watch carefully. They fit together perfectly. Not into another triangle, but into a perfectly straight line. Since a straight line measures 180 degrees, the three angles of the triangle must also add up to 180 degrees. It's elegant. It's convincing. But perhaps you're wondering, why do those pieces fit together so perfectly in the first place?
The answer begins with a single extra line. A line drawn through the top of the triangle, perfectly parallel to its base. At first glance, it doesn't seem to do much. But parallel lines come with a remarkable property. When another line crosses them, certain angles are forced to be equal. This angle here is exactly the same as this one, and this angle is exactly the same as this one. So although our triangle appears to have three separate angles, they're secretly hiding along one straight line. And a straight line measures 180 degrees. The mystery disappears. It wasn't a coincidence after all. It was hidden inside the geometry of parallel lines. But there's another way to see the same truth. Imagine you're walking around the edge of the triangle. Every time you reach a corner, you have to turn. One turn, then another, and another. By the time you've returned to where you started, you've made exactly one complete rotation, 360 degrees. Each turn is related to the triangle's interior angle. Put those relationships together, and once again, the interior angles must total 180 degrees. A completely different journey leading to exactly the same destination.
So, have we finally proved that every triangle in the universe has angles adding to 180 degrees? Not quite. Everything we've done so far assumes that we're working on a perfectly flat surface. But what happens if the surface itself is curved? Let's draw a triangle on a sphere. The three angles of the triangle are 90 degrees, 90 degrees, and 90 degrees again. Their total isn't 180 degrees, it's 270. In case of a triangle on a hyperbolic plane, the angles add up to less than 180 degrees. The triangle didn't break the rules. The rules changed because the geometry changed.
We began with a simple question. Why should the angles of a triangle always add up to 180 degrees? Along the way, we cut the triangle apart, drew a single parallel line, walked around its edges. 4 completely different ideas, 4 completely different perspectives, yet every one of them revealed the same hidden truth. That's one of the most beautiful things about mathematics. A theorem isn't just something to memorize. It's a landscape that can be explored from many different paths. And when every path leads to the same destination, you know you've uncovered something fundamental. Thanks for watching.